In the last video, I dealt with linear factors in the denominator, and I'm also going to deal with linear factors here, but I'm going to deal with repeated linear factors. So let me show you how that works, and so now you'll kind of understand what those guidelines are saying. So here I have a rational function here, and notice I've got in the denominator I've got one linear factor, but x plus 1, but it's by itself, so I can treat that factor like I did earlier. Now here I have x minus 2, but that factor is repeated 3 times because it's raised to the third power. So actually I'm going to have 3 terms for that one. I'm going to have one for x minus 2 to the first power, I'm going to have one for x minus 2 to the second power, and I'm going to have one for x minus 2 to the third power. So let's see how we can write this. So this fractional expression can be written as a over x plus 1. X plus 1 is to the first power, so I just have that once. And then I'm going to say b1 over x minus 2 plus b2 over x minus 2 squared plus b3 over x minus 2 cubed. Now, the LCD is x plus 1 times x minus 2 cubed. So if I were to multiply the left-hand side by that, of course, what that would do is that would simply just eliminate the denominator and just give me this expression. Now, if I multiply the right-hand side, each term by that, well, here's what's going to happen. So remember, if I multiply each one of these terms, let me circle this. So I'm going to multiply, if I multiply this term by the LCD, then the x plus 1's will cancel, and I'll just get a times x minus 2 cubed. Then if I multiply this term by that, then one of the x minus 2's will cancel, and I'll have b1 times the x plus 1, and then times 2 of the repeated x minus 2 factors. And then if I multiply this term by the LCD, then 2 of the x minus 2 factors will cancel. So I'll have b2 here times x plus 1, and then times only one of the x minus 2 factors would remain. And then finally, if I multiply this term by this LCD, then all of the x minus 2 factors would cancel, and I would just have the b3 times the x plus 1. Okay? Now, we could multiply all of this out like we did last time, but the problem is, you know, I have x minus 2 quantity cubed. That's going to be a mess to multiply. X plus 1 times x minus 2 quantity squared, that's going to be a mess to multiply. Now this wouldn't be too bad, this FOIL here, and then I could distribute here. But actually, there's a better way. If we can pick certain numbers to simplify this, okay, let me show you what I'm talking about. Notice here that if I were to let x equal 2, notice that this term right here would disappear because I'd have a times 0 cubed. And then this term would disappear because I'd have a factor of 0 here. And this term would disappear because I'd have a factor of 0 here. So, and since the left-hand side equals the right-hand side, then whatever the left-hand side equals when x equals 2, then the right-hand side would equal the same thing. So let me show you what we're going to do. We're going to plug 2 in on the left-hand side. So if I plug 2 in on the left-hand side, I'll have 3 times 2 cubed. That'll be 3 times 8, which is 24. If I plug 2 in here, I get minus 18 times 4, so that's minus 72. If I plug 2 in here, I get 29 times 2, which is 58, and then of course I have minus 4. So on the left-hand side, I have 24 minus 72 plus 58 minus 4. All that just equals 6. Now let's look at what happens on the right-hand side if I plug 2 in. Remember what I said? On the right-hand side, this term disappears. It's going to cancel. This term's going to cancel. This term's going to cancel. So all I'm going to have is the b3, and then I'm going to plug 2 in here for x. So I have b3 times 2 plus 1, which is just 3b3. So on the right-hand side, I get 3b3. So on the left-hand side, when I plug 2 in, I got 6. On the right-hand side, when I plug 2 in, I got 3b3. So now I can easily solve this for b3, divide both sides by 3, and you see that b3 equals 2. So that's one way. All right. Now, another good number to choose, since I have an x plus 1 that shows up in 3 of these terms, I could let x be -1 because that would make this term, and this term disappear. So let's see what happens if I let x be -1. Now if I let x be -1 on the left-hand side, I get 3 times -1 cubed, so that's going to be -3. Then I get -18 times -1 squared, which is just -18 times 1, -18. And then I get 29 times -1, so that's -29, and then the -4. Now if you combine those 4 terms, you get -54. All right, now let's see what I get if I plug -1 into the right side. Well, remember, if I plug -1 into the right side, all 3 of these terms will disappear because it'll give you you'll have a 0 factor in them. And then if I plug -1 into this first term, I'll get a times what's -1 minus 2, -3. What's -3 cubed? -27. So I get a times -27, which is -27a. And so now I get -54 on the left, -27a on the right. Divide both sides by -27, and I get a is +2. So I've got the a and I've got the b3. So now I've got to get clever and figure out what the other values are. Okay, so I've got the a is 2 here. Let me clean that up there. All right, so I know a is 2. I know b3 is 2. Okay, so now another good number that might be helpful, I can't really plug anything else in here to make those disappear, but what I can do is I can plug 0 in, because 0 is usually easy to work with. So now let's plug 0 in on both sides of the equation. Now on the left, if I plug 0 in up here, I'm just going to get 0, 0, 0, -4. So I'm just going to get -4 on the left. But if I plug 0 in on the right, I'm going to get a times -2 cubed. All right, and so that's going to give me, oh, remember a, we already know what a is. Remember, we know a is 2, so we can actually go ahead and replace a there. So we get a, which is 2, so I have 2, and then plug 0 in times -2 cubed. Now, I don't know what b1 is, so I'll just bring the b1 down. And if I plug 0 in here, I get 1. If I plug 0 in here, I get -2 squared. So 1 times -2 squared. And then I don't know what b2 is, so bring the b2 down. And then plug 0 in here, and I get 1. Plug 0 in here, and I get -2, so I get 1 times -2. And then remember, I know b3 is 2, right? So b3 is 2, and if I plug 0 in here, I get 1, so I get b3 times 1, or 2 times 1. Okay, now, so if I simplify all this, that's going to be -16. That's going to be 4b1. This is going to be minus 2b2, and this is going to be 2. So now let's see, that's going to be -16 plus 2 is -14. And then if I add 14 to both sides, I'll get 4b1 minus 2b2 equals 10. Okay, so that gave me an equation involving b1 and b2. Now let's pick another simple number. This time let's plug x equal 1 in. Now 1's not as nice as 0, but it'll help. So let's plug 1 in. So if I plug 1 in here, I get 3 minus 18, which is -5. -15. 3 minus 18 is -15, plus 29, that would be 14, and then -4 would give me 10. So if I plug 1 in the left, I get 10. And now if I plug 1 in to the right side, remember a, we knew it was 2, so I would get 2. So I get 2. And if I plug 1 in here, 1 minus 2 is -1, so I'd get -1 cubed. And then b1 we don't know, but if I plug 1 in here, I get 2. If I plug 1 in here, I get -1 squared, which is 1. So I get b1 times 2 times 1 there. And then b2 I don't know, so I bring the b2 down. If I plug 1 in here, I get 2, and 1 in here, I get -1. So I get b times 2 times -1. And then b3 we know is 2. And then if I plug 1 in here, I get 2. So I get 2 times 2 here. Now, so if we simplify the right-hand side, 2 times negative 1 cubed, that's just going to be minus 2 right there. And then this is going to be just 2. 2 times negative 1 squared is 2, so I have 2b1. And then 2 times negative 1 times b2 would be a minus 2b2, so that's where I get the minus 2b2. And then 2 times 2 is 4. Okay, so now I can combine the minus 2 and the plus 4, and I'll get a 2 right there. And then if I subtract 2 from both sides, it'll give me 8 on the left, and then I have 2b1 minus 2b2 on the right, so there's no reason why I can't turn that around and write it like this. And so now I have that equation with b1 and b2, and I have this equation with b1 and b2. And so when you put these two equations together and solve them for b1 and b2 using either the elimination method, well, that probably the elimination method would work. So solve them, and I'll let you solve this system. And now the solution of that system is b1 equal 1 and b2 equal negative 3. So now we have all four values. We knew a was 2. Now we know b1 is 1. We know b2 is negative 3. And we knew b3 was 2. So now if you go back up here, what we said earlier, it has to equal this. Now we can fill in the a, the b1, the b2, and the b3. And now we know how this breaks down. So now this breaks down into 2 over x plus 1 plus 1 over x minus 2 minus 3 over x minus 2 squared plus 2 over x minus 2 cubed. And so that means that if I wanted to evaluate this integral, I could rewrite this integral as the sum of these four terms. And then this one, you know, you can integrate 2 over x plus 1 using the integral for natural log of the absolute value. And then the same thing here, if 1 over x minus 2, that integrates to the natural log of the absolute value of x minus 2. Now these two you have to use the power rule. So on this one you have minus 3 times x minus 2 to the negative 2 power. And then this one, you're going to integrate it. It's going to be 2 times the integral x minus 2 to the negative 3 power. And on these we can just use the power rule. So I'll just go ahead and show you that I did that. So if I use the power rule there, I'll get minus 3 times x minus 2 to the negative 1 divided by negative 1. If I use the power rule here, I get 2 times x minus 2 raised to the negative 2 divided by negative 2. And then, of course, plus c at the end. And then just simplify this mess. Minus 3 divided by minus 1, that's plus. And then 2 divided by minus 2, that's going to be a minus. So you're just going to have minus 1 times this. And I went ahead and moved these to the denominator so I could write the exponents as positive. So x minus 2 to the negative 1 would be the same as x minus 2 in the denominator. And then x minus 2 to the negative 2 would be the same as x minus 2 quantity squared in the denominator. And then these two that I was able to solve immediately using the du over u integrals, then I just bring those down. So I actually have 4 terms. So I have, this is the value of the first integral, this is the value of the second integral, this is the value of the third integral, this is the value of the fourth integral, and then of course plus a constant. Okay. Now, so to wrap this video up, I've given you a couple of practice problems here. So this one can be written as 3/4 times this integral plus 1/2 times this integral plus 1/4 times this integral. And so I'll let you show that, and you should be able to evaluate the integrals once you get there. So see if you can get this. And then this one here, I have actually repeated factors here, x plus 2 quantity squared. So remember, in that case, I'm going to have that's going to break up into something over x plus 2 and then something over x plus 2 quantity squared. So that should break up into 2 integrals. And so you can determine what those are by using this partial fraction decomposition. And that covers the problems with linear factors. And I'm going to show you some other examples in the next video.